Alright, today we are looking at page 330, lesson 13-5, similar figures. Alright, so we're looking at similar figures and what are the properties of similar figures. So let's start down here and write down this definition. Pause me once you get it down and then push play. Alright, similar figures. They have the same shape but may or may not have the same size. A lot of times when we're talking about similar figures, they don't have the same size, but they're the same shape. More importantly, corresponding sides of similar figures are proportional. Okay, what this means is, if I look at the ratio of width to length on this box, it's going to be equal or proportional to the width to length of this box. And we can use that to solve and find this length that's missing. So the question is up here, if a small box 2 inches wide, okay, and 9 inches long, so that's the ratio of width to length of that box, 2 inches to 9 inches, was enlarged proportionally, which would make it similar, to be a shipping container of 18 feet long, how wide would it be? So we have this proportion and we don't know, notice this is width on top to length. We don't know the width, but we do know the length of this one. So these two boxes their ratios are going to be proportional. These corresponding sides of similar figures are proportional. Let's look at the next page. Okay, step 1, write a proportion. Basically what I did on the other page here. To find the width of the shipping container, use X for the width of the shipping container. So they set up this proportion. We have the first box here, and we have width to length. The second container here, same setup, width to length. So box 1, width is 2 inches, length is 9 inches. Container 2, width is, we don't know, X, and container length is 18 feet. So now that you have your proportion set up, you can solve for it. Alright, so now you can go ahead and use your cross multiplication here and multiply 2 times 18 to get here, and 9 times x gets you 9x. Again, we want to get x by itself. We're solving for x. We want to divide by 9 to get rid of that multiplying by 9. This becomes 36 over on this side, divided by 9. And, which I guess I could have shown down here, which would be a little better. So 36 divided by 9 gives you 4, so the container would be 4 feet wide. If I was going to plug that back in, erase this, and I would put my 4 up here, and that would give you that proportion. So we know that the container is 4 feet wide. Alright, we're going to look at this another example here on page 330, how you can find missing measures from similar triangles. Okay, so triangles ABC, this one on the left, and EMH over here on the right are similar triangles. And what they want you to do is find the length of line segment, that's what that sign means, that symbol means, over HM, point H and point M. They want to find this length of this line segment here with that question mark beside it. But what you need to know is, what does it mean when they say triangles are similar? So what it means is the corresponding angles of similar triangles are congruent. So one thing it means is you have to find the corresponding angle. So just looking at these shapes, you can see right away I've got my obtuse angle here and here. So these two angles are congruent, meaning, and they show that right here, angle A and angle E are congruent, meaning they have the same measurement here. And they show that by these 2 hash marks that they put here. Both of them have 2 hash marks if you look really closely in your book. Now once you figure out one congruent angle, usually it's easy enough to find the other congruent angle. So I would say then angle C here and angle H are congruent, and they show that up here with one hash mark on each of those to show that they are congruent yet different from angle A and angle E. And that's what this says here, angle C and angle H are congruent, and that leaves then M and B with the 3 hash marks here. These two angles are also congruent or equal, or the same measurement, same degree. Alright, so because of that, then corresponding sides of these similar figures are proportional. So that means, like they say here, AC, this line segment, and EH, this line segment, is going to equal, just pick two other corresponding sides, AB and EM line segments, or I could say CB and HM. Let me erase this so we can look at this a little bit better. Now the question is, since we know that, CA or AC, whatever I want to call this, and HE over HE could be set up to equal AB over EM, or CB over HM, what is the length then of this line segment? Alright, so first thing they want you to do is set up a proportion here. Pause this first. Alright, so step 1. Write a proportion. Use corresponding sides of triangle ACB and triangle EHM. And let X be this length of line segment HM up here that we don't know. So what they do is they put line segment AB right here over the opposite triangle, the similar triangle, corresponding side, EM, which is 2 over 3. Okay, and then they do the same thing. Let's then put CB, first triangle, 5, line segment, over HM, that corresponding side that we don't know, which is X. So now, second step is solve your proportion. So you can cross multiply. So 2x equals 3 times 5, 15. Divide by 2 to cancel that out and get x by itself. 15 divided by 2 is 7.5. So this line segment is going to be 7.5 inches in length. Okay, on page 331 on guided practice, I'd like you to try and solve for 1 and 2 here. What it says is the rectangles below are similar figures. So in 1 and 2, use proportions to determine the length of the missing sides. So use this width and this length to find, we know this width, but this length. And then do the same, because all three are similar, you can do the same with this shape to find the width here. This one has the length. Set up your proportions. Bring your work to class tomorrow and bring a question. See you tomorrow.